So here, we just got done talking about the empirical rule. And the thing about the empirical rule is you have to assume that the distribution is bell-shaped. So what if the distribution is not bell-shaped? Well, what do we do, right? How do we do this? Okay? So the Chebychev's rule, right? I'm not making this up. So this theorem says that the portion of any data set, so that means it doesn't matter what the distribution looks like. The distribution could be bell-shaped. The distribution could be wiggly, 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 wiggly. The distribution could be bimodal. Whatever the distribution, it's any distribution set lying within k standard deviations of the mean. Okay? This is equal to at least 1 minus 1 over k squared for k greater than or equal to 2. Okay? So if k equals 2, how do we interpret this? Well, if I plug a 2 in, that gives me 1 over 1 divided by 2 squared, which is 1 minus a fourth, which is 3/4, which is 75%. So k equal to 2 means at least 75% or 3/4 of the data lie within 2 standard deviations of the mean. Okay? Now, at least is a very powerful word, because if you think back to the empirical rule, the empirical rule says that in 2 standard deviations, how much of the data lies in 2 standard deviations? 95%. So does that satisfy Chebychev, or does Chebychev destroy that? Well, when I say at least 75%, 75% at least, I think 95% qualifies, because 95% is at least 75, right? If somebody says, man, I've got at least $2 in my pocket, that means they've got $2, they got $3, they might have $4, anything 2 or more, right? So at least 75% means 75% or greater. 95% is definitely greater. So it doesn't contradict the empirical rule. It just says that at least 75%. It's giving you a lower bound. So if k equals 3, that's 1 over 1 divided by 3 squared, which is 1 minus 1 over 9, which is 8 over 9, which is roughly 88.9%. Okay, 88.9%. So that's a big amount. That's not quite the 99.7 that the empirical rule promises. But here it says at least 88.9% of the data lies within 3 standard deviations of the mean. Okay, so this is the idea of Chebychev's theorem. Okay, let's use an application where we have Chebychev's theorem. So data set has a mean of 35 and a standard deviation, population standard deviation, and population mean. Okay, so the distribution is unknown. Now, since we don't know the distribution, what does that mean? Do I use the empirical, or do I use Chebychev's? Well, since I don't know the distribution, I have to use empirical, because this assumes it's a bell-shaped. Okay? And I don't know that it's bell-shaped. So I have to go with Chebychev's theorem. Now, is the entry 100 unusual, right? So how do I figure this out? Okay? So what is unusual? Well, K equal to 3 standard deviations. What does Chebychev tell us? It tells us that that's at least 89.9%, right, of the population is between, well, what is it? It's between 3 standard deviations one way and 3 standard deviations the other way. So how do we get those two numbers? I'm going to take, well, if you want to go in a number line, maybe that's helpful. What's in the middle? Mu is in the middle at 35, right? If I go 1 standard deviation over, that's mu plus sigma. So that would be adding 20. So that gets me to 35 plus 20, which is 55. Okay. And then I go over another one, that's mu plus 2 standard deviations. So add another 20, that's 75. And then I go over this way, and I have mu plus 3 standard deviations, and that's 95. Okay. Now going this way, I subtract 20, and so 35 minus 25, minus 20 is, I guess, 15. And I subtract 20 again, and I'm going down, that's like -5. And I subtract 20 again to go out 3 standard deviations this way, and that's like -25. That's way away from 0, right? So what does this say? We're like almost an 89% chance that we're between these two values here. Like there's basically an 89% chance, right? That we're between. So at least, probably more, but it's at least this 88.9. So between -25 to 95. So is 100 unusual? Well, I would actually say that 100 is unusual, okay? And the reason I would say that it's unusual is because it's outside of this range. 100 is like way over here. Like that's way outside the range, right? Okay? So my range here is already pretty wide, and I'm still outside of that. Okay? So what we're going to say in general is that if we have 2 or more standard deviations away from the mean, we're going to define that to be unusual. Okay? Now 3 or more standard deviations away from the mean, I'm going to define that to be very unusual. Okay? Now, if you guess, guys, just common sense, if you're very unusual, are you unusual? Yeah, I think so. If we're very unusual here, then I think there's a good chance that we are unusual as well. Okay? So this is definitely unusual. And not only is it unusual, it's a very unusual outcome.